Hello, and welcome to another stream. And I'll just check. Whoa, yeah. Apparently, the volume controls are back to normal, so I should be audible. That's good because last time I wasn't audible for a bit, and that's sad. Although I didn't really say anything of consequence, so you know. Okay. If you're in chat, say hello. Um, as always, I'm taking song requests. Whoops. Where did we get to yesterday? That's a good question. I can't really remember. Ooh. Oh yeah, make rooms rendering rotated to reference frame. I fixed up the bounds checker. So now, if we look at, for example, this room, has that big block in the top right upper corner. If we go down and look at it from here, it should be down the way. If we go down another room, it should be in the near right lower corner. If we go down once more, it should be in the near upper right. So up here. And once more, it will have returned down to, or back to its original position. Okay, yeah, that's pretty good. I just remembered that you can do this. Whoa, that's very disorienting, but you can, there's no bounds on the mouse. Very unpleasant. Yeah, and we can fly around and see the same rooms in different combinations. It's all very exciting, except not really, but whatever. Oh, I can strafe run for extra speed as well. That's exciting. Well, it's a thing. Okay. So that's holonomy in a basic sense implemented. And we can now move around the tesseract, retaining our reference frame and seeing the rooms of the faces of the tesseract, which are rooms, in the corresponding reference frame. Cool. As always, everything in this game has its own reference frame. Okay, I had some notes for what to do today. One of the things I wanted to do was split up the rendering. Instead of each room rendering itself, it should build a mesh, and there should be some tool that has all the shaders, and the meshes should get combined and all that kind of stuff, which is kind of exciting in a way, but not really, because it's a bunch of changes that will amount to the thing looking exactly the same but being better structured behind the scenes. And the other thing in my notes is to implement a trace line function. So you look in a certain direction and it tells you, it sends a line out, calculates what voxel part of the room you're looking at. Which might be a bit of fun. I mean, I could just stick it right here. Trace line. Should be trace line or trace line. Well, trace line isn't a word, so it should be trace line. See, it's important decisions like this that really matter. Should I put one letter as uppercase or lowercase? So trace in the world and in a reference frame. That world could be constant as well, because I'm going to change it. I might actually split this up into a separate file with its own data structures. From a position and along a line or array really. And it should probably return something, but whatever, let's just start thinking about it, and then we can figure it out and everything will be okay. So the world is just these 8 rooms arranged in like a tesseract. A reference frame is a position or a reference frame inside one of the rooms. The position in that reference frame is a specific position, and the line within that reference frame will be a line which could cross into other rooms and other reference frames. So this isn't going to be useful. This will need to have a structure that it'll output, because it's going to need to output things like how far along the line you got, the end reference frame, the end position in that reference frame, the normal, and maybe the same thing inside the room reference frame. Yeah, it's fiddly. But let's just say it's within the one room so far. Whoa, there's something down there. Oh, it's a bottle of juice. Okay. So what's the principle of tracing a line through voxel space? It's Jinx Crivens, who has been at my computer. My kid has been at my computer. I open up MS Paint, which is not actually MS Paint, but the sheer white screen highlights how smudged this screen is. Sorry, this is probably really loud on the mic, but I can now see under the fingerprints what I'm really doing. Okay, so let's just do a 2D example. I don't know why I'm drawing a box so badly when there's a tool for drawing a box. Let's make this into a little grid. Pixel skills. It doesn't need to be big. I've cleaned it up, so it should be a lot clearer. How's it going, Marcos? I'm doing a trace line function that goes, or eventually will go into different reference frames in different rooms. A cool thing about this is because it's a non-Euclidean topology, the tracing a line can actually loop. Okay, so I don't really sometimes I work these things out beforehand and then stream them, but this one I'm kind of just winging it. I've done it in the past and it's not super hard. So you're starting at some point somewhere in the grid, and you have some motion you'd like to undertake to some other distant point. That's your start point. So the points you actually need to figure out, which I'll mark in the pink, are here and here, basically where you cross into new cells. A bit like the Bresenham line drawing algorithm. So how do you know the first cell transition you're going to make? Well, it's going to be either this way or this way, because that's the direction the line is going. You can find that just from the sign. Are the corners literally corner cases of these kinds of computations? I wonder if edge case and corner case came from doing something on a grid like this. I could believe it. But well, corner cases and edge cases are not actually super tricky. For the start point, you just chuck it into whichever cell you think it's in, and if you're wrong, then it'll just cross into some other cell. I think my old previous prototype thing, I think you could get it to crash by looking directly downwards without moving. Or is it directly up? There is definitely, maybe it's at a certain angle. There is definitely ways to code it such that it does a bunch of divide by zeros and gets really unhappy. So, yes, there are corner cases that are somewhat literally because of corners. So it's either going to travel this far or this far. These values are pretty easy to work out. Which is it going to do first? Well, it depends exactly the rate it's traveling. So if this is traveling it's not if it's traveling more upwards than along, but if the you can work out how far along the line will it cross this edge, which is it's going to travel what, about 2.1 units, and this is like 0.7, so it's going to be well, of course, 1/3 of the way along, so 33%. And how far until it hits that edge? Well, it's traveling, that's like 0.8, and it's traveling, let's say 1.6. So that's going to be like, no, it's not 1.6, it's like 1.4. I'm trying to make the maths easy. So 0.6 over 1.4, it's going to be like 42%. That's definitely wrong. Yeah, it's traveling. Oh, that's more like 0.8, not 0.6. 57%. Yeah, that looks a little bit better. So it's going to be 57% of the way through the path when it crosses this, and it's going to be 33% of the way through the path when it crosses this. So that means the first thing it'll do is cross there. And then you can work out when it crosses this one, which is going to be, you know, about 80% of the way through, whereas now we know this one is about 57, so we know it's going to go that way and then that way. And that will work in general if you have a big long line that does some complex pattern of, like, you know, up, up, right, up, 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 right, up, 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 right, or something. It has to be periodic, but it can be a bit fiddly. And it's three-dimensional, so it can go, you know, forwards, forwards, right, forwards, up, forwards, forwards, right, forwards, up, forwards, or something like that. But the important thing is it's not super difficult to work out. So for each axis, let's start more at the beginning. So first of all, work out what cell did I call them cells? What did I call them? Voxels. What voxel coordinate they are in? Okay, so you're going to work out what voxel you're in. Then work out distance, or wait, sine of line motion. I'm thinking about reference frames here. So the easiest thing to do would be to convert all this stuff into the room reference frame and then just blast through it like that. But then if you cross into a few other rooms, you just have something in some room reference frame. Whereas I want to preserve the reference frames correctly when tracing a line, because it's important for, so if, how can I explain this? I guess jumping into the actual game would explain it better. So I'm currently in some reference frame. I'm actually in the same reference frame as the room, but let's change that. If I go over here and down, back into the same room. Now I'm in the opposite reference, I'm upside down compared to the room. So that's the floor of the room, but that's above me because my reference frame and the room's reference frame are different. Now say I want to trace a line forwards from where I'm looking, like here, and it was hit somewhere on this wall. I want to preserve the reference frame of that line, so I get a position. Sure, I want to know what voxel it hits, but I also want to know, like if I want to teleport myself there, I don't want to just teleport myself to that position in the room reference frame, because, well, then I'll be like 90 degrees out from where it should be, because that reference frame is different from my reference frame in that room. So whilst checking the voxels requires it to be in the room reference frame, I don't want to just chuck away all reference frame info, because it is actually important. It's not important for a point, but if it's like using the line to like move an object or something, it does matter. So work out sign of motion. Then what do we do with that? We work out how. Oh, so this is actually for each axis. How far along the line each cell transition is. Pick the smallest cell transition, and we want to do this repeatedly while t, which is going to be the parameterization, as in how far along the line. So if we're here, we're tracing a line this way. If it gets all the way to the end, it's going to be t is 1, and if it doesn't get anywhere, t will be 0. If it stops maybe here, that's like 55, 60%, whatever. So t would be 0.55. So you can multiply your line by that fraction to get the end position. Kind of, that's assuming, whoops, that's assuming you're in the same reference frame, which you probably won't be. So while the t, the parameterization, is less than 1, that'll get you to the final cell. And what sort of things do we want to find out? Final reference frame, normal, end position, end voxel coordinate. Is that all? Probably not. I imagine we probably want other stuff, but we want at least that much. Probably. Okay, work out what voxel coordinate you're in. So if you want to convert from reference frame position to voxel coordinates, you need to first transform to room basis. And then you need to add half room size and cast down to integer. So the rooms in the voxels start from 0, 0, 0 and go up to 31, 31, 31. It could be gold cube. And in terms of coordinates in floating point, the rooms are centered on 0, 0, 0 and go to positive, negative 16. Or whatever, depending on the room size. It can be different. Apart from a couple places where I assume it's not. So the only way I can think to transform this is just the same way it was done yesterday, or the day before rather, in last time, the way it was done last time. In the rendering where it was gosh, it was a transpose of the target matrix multiplied by the source matrix. Is that right? I think that's right. So in this case, the target matrix is the room base matrix, which is world, rooms, RF side, basis. So that's transpose of that multiplied by the matrix from the reference frame. So this transform should push you from that reference frame into the room's basis reference frame. Nobody disagreed, so that means it works. I don't have an expression to show how faulty that idea is. Right. I think see, this is something that always bugged me. Is there like a shortcut to multiplying a vec3 into a map 4? Or do I just have to form a vec4 out of vec3, then multiply it through, and then convert back to vec3? Because that's what I've always done in the past. I'm just googling Stack Overflow. And nope. People on Stack Overflow say just make it a vec4 and then just do it that way, and then you just drop it back to vec3, which makes sense. It does indeed make sense. Vec4. This is a position, so let's do that. It won't make a difference. Why? To that. Okay, so let's. The line should have 0. These need to be 44. Okay, transform to room basis. Done. Possibly. Add room half size and cast down to integer. Well, you can use glm I, or is it ivec3? ivec3, yeah. voxel pause is room pause. Let's do glm floor room pause plus world's rooms rf side dot size. That's half of that. Bish bash bosh. We've got the voxel pause. Okay. Oh god. It's messy. I'm sorry it's messy. I'm not that sorry. If I was sorry I'd tidy up more. But it hurts my legs, so I don't. So I'm trying to tidy quite a lot. Okay, so we now have voxel position for where we are. And now we do some hacks. This is where we get hacky. We're just going to set the voxels. Look at that. Ha! Ha ha! Can I just set the room? Probably need to conscast this. World rooms, RF side, that's TF. Can I just do that? Well, it's not because it's. Yeah, oops, I need to conscast. Oh, I don't actually want to conscast this, but for now, this. I don't know. Why have I done this? So, it looked like it was getting good, and then I was just like, bang. Just set that voxel that you start in to a solid voxel. And then that's it. That's all you get. Why? Well, it's easy. I don't know if any of this really works. Also, I don't even know if rebuilding the room geometry works, so this is testing a bunch of stuff that's currently untested. I'm also going to add an action button. And I'm gonna hook it up to the mouse button. Just implementing things willy-nilly. Is button press, SF, mouse, left. There we go, we've got an action button. And because this is standardized in the control system, that's already exposed to the script. And I'm going to go even one step further. I cannot be stopped. I can easily be stopped. Set position is what? Let's just add in m script bind test. And it's going to take an entity ID. So we've got a test function for an entity. There's currently no way for entities to appear, they're invisible, so the only one that we really care about is the player. So for only that entity, I want to get its position if it has one. If it doesn't, it's not going to do anything. Actually, it's going to assert. So we've got a reference frame and a position. I want to call trace line on the world and world. Reference frame, that's here. Position, and the line I'm tracing is gonna be obviously I guess just like 5 units in the X direction. Who knows? That we'll figure out later. Bang! We've got everything we need to start tinkering. 100% tinkering. Okay, let's look it up in Lua, right? If is button, did I do an is button swapped? Is button down, button dot action, which I haven't set up, and is button swapped, button action, then. Oh gosh, I'm just going all over the place. Jump. Action should be 5, hopefully. Okay, then we want to call a test function for the player, whose entity is stored in the player variable. That doesn't actually... Right, let's give it a roll. Let's see what happens. If this works, it should place a voxel under the player, and then it should rebuild the frame, so you'll be inside a little box. Well, that's interesting. It definitely... So what I can tell you straight away is that rebuilding the room seems to work. Picking out the right reference frame definitely did not work at all. It kind of, I can see some symmetry. Not quite, because it seems both sides. But like, it's following my movements in some manner, so it's not a total... It's not a total crap shoot. So if I go down... I had a feeling what I've done is wrong. Which is fine, it's okay. And I think what's wrong is this is nonsense. It doesn't look like nonsense. Let's just try the stubborn approach. Maybe I got them back to front. I don't think I did, but then again I thought it was correct and it's not. Well, I didn't just get them back to front, that's the good news. I don't know how good that news is though. There's some sort of diagonalness to this. Or is there? Let me actually check, did I actually... Oh, XYY classic. Let me just move those back. And let's use XYZ. Gosh, that's a classic, isn't it? Oh, that looks a lot better, doesn't it? If I move backwards... Oh, let's go on a quest. We're going to go to, I'm just clicking a lot. We're going to go down to the green room, straight through the yeast room and the X-ray room, all the way to the watermelon room. Whoa! Back to the green room again. We're in the zinc room, and we're going back to the bluey room. Let's see if we can trace our path. Our holonomy's changed, but it looks pretty good. Looks good indeed. Straight through the red room, back to the green room, through the zinc, and back to the water room. Excellent. Excellent, excellent. So that was sloppy. I can only apologize. But that's also why it's cool to have things rigged up to do things. Ooh! Oh yeah, that's right on the edge. You should be able to set a voxel right on the edge. Let's just... there we go. There should be some coherence, so if you set a voxel on one side, it should set on the other side as well. There we go. Ooh. Very nice. Yeah, it's good to see it with stuff in the rooms in all different ways. Whoa. Whoa. Climbing, climbing, climbing. Good fun. Okay, I'll stop playing. Games are for gamers. So that does indeed move it into the right form. Oh, wait. So I'm going to play around a bit more. I should take this out. Let's do block comment in Lua, which has a very strange format. And now I should be able to just, wow, hold it down. Oh yeah. Oh, look at that. Beautiful. Oh, it's actually possible to go diagonally more easily than I thought. Yeah, look at that. Straight diagonal jumps. I thought it would be a solid line. I can connect it up. Cool, now we've got a path. Oh, look at that. Beautiful. Or we can go down a couple. Or along and then down. No, I forget what I'm doing. Oh, now it's falling. Okay, whatever. That was actually not relevant, but I do like that you can draw lines. Anyway, back to tracing lines. So we know we've got the right voxel pause. And we can therefore probably assume that the room line and the room pause are correct. The room pause must be correct because it's used to calculate the voxel pause, which is correct. Generally, two wrongs don't make a right. Well, don't quote me on that. So, I had to work out the sign of line motion. So, is there a sign function in GLM? Sorry, does that return an IVEC? Gen type. Okay, let's just assign. There's not a good sign function in room line sign, sign of room line. Now that it's converted. Okay, so now we know if we're going backwards, forwards, or not at all. So how do you work out the next edge? So back to the MS Paint example. It is very warm in here. I'm going to turn the heating off. Sorry about that. So back to this example. We're at some position. We know what cell we're in, but we need to know how far it is to the edge of the cell, which does depend if we're going, so if we're going left, it's nice and short. If we're going right, it's long. In fact, it's this length, or it's 1 minus that length to get that one. The cell is 1 unit wide. Okay, cool. So if it's negative, it's that. If it's positive, it's that. Oh, we could probably just do this in a one-liner. Room line sign is -1 if it's negative, +1 if it's positive, 0 if it's 0. We don't really care. Except we kind of need to know that in the future, but let's just not worry about that right now. So let's just do it's 0.5 plus 0.5 times room line sign. That does is that's going to be 0 if it's negative, or 1 if it's positive, minus room pause minus voxel pause. I'm just making more and more vectors. Next edge. So that is that right? So room pause minus voxel pause is basically, if this is your room position, it's in this case 1, 1. This is going to be like 1.2, 1.3. So subtracting them, you'll get 0.2 by 0.3. You'll get this distance here. And it doesn't like to subtract a vec3 and then I vec3. Can I just cast this up to a vec3? Okay, cool. So why is that going to work? So if you're going negative, it's 0. If you're going positive, it's 1. So it's going to initialize that with which edge you're going to. I mean, that might actually make more sense. It's the edge. So it's either going to be 1 or 2. If it's positive, it's going to subtract this distance. Subtract this. This is probably fine, yeah. I think. I don't think I've explained it very well, but I'm pretty convinced that's the right answer. Although if you have a 0 there, you get some voxel position plus 0.5 plus 0.5 times 0 minus wherever you are in that. Ah, okay, whatever. So next, I stopped reading what I wrote. Next edge. So you've got your line. You've got your next edge, which will have some value for how far it is to each edge. The absolute room line, because we're now just going to treat it like positive because we just want the proportion. So what did I say before? That divided by that entire length is the t value when it gets there, and this divided by this entire length is the t value when it gets here. So divided by abs room line I'm tired, and this is turning out very messy. But that's okay. I can like work on simplifying it later. So now you want to do if tx is less than ty and tx less than tz, so if x is the number one thing, then I want to translate the x axis. Else, if y is less than z, translate on the y axis. Otherwise, translate on the z axis. So that's the basis of it. But we also want to know room line sign is a thing, because we don't want to try translating on an axis that has nothing going for it. What if they're all false? A mystery. One of many edge cases that this will no doubt cause. This is very messy, but that's fine. Just believe in yourself. Okay. We probably also want to check the signs, so you don't want to compare it if the y-axis is least. Like if you're not moving on the y-axis, you don't actually care your x value could be bigger. It's not going to get, it shouldn't. It's not quite right. So what does translating on the x-axis imply? Voxel pos.x should be added to by room then what? The next edge for x well, what is it? Is there some formula to this? So if this line was really long, every time it translates here, the next jump is going to be the same percentage of the thing. So let's try. Oh, I'm tired. Let's try explaining what I mean by that. I'm just going to draw a bigger grid. Well, a finer grid. It's probably going to be actually a lot smaller. Oh, no, it's going to be about the same size. A little bit smaller, a little bit. So my intuitive thing to say is that if you move... I try not to pick the center because that kind of makes things awkwardly easy. So from here to here, I'm trying to find a color that stands out on red. There you go. From here, sorry if you're red green colorblind. From here to here to here to here to here. Yeah. I'm wagering that these are all the same. Yeah, there's like an even spacing between them, and these other ones, oh, my color choices today are off the hook. That and that and that and that are also evenly spaced. So when you do you make the first move, so you're in this cell, first move is to this cell, you know, the next, you can just straight up calculate what the next green thing is. So what's it going to be? It's going to be it's just going to be 1 over abs room line dot x. As in, that's the length you're traveling and that's the total thing. So the proportion of the line traveled in that direction is 1 over distance over total distance equals fraction of distance traveled. So abs room line is only ever used in terms of division, so let's just change it to edge fraction next edge times edge fraction. Okay, cool, go. Okay, and I also want to float t. I don't want to call this t. This is like next t. Next. It's got t in it. This is very messy. I do want to tidy this up a bit. It's also got a lot of edge cases. So t is going to start at 0. And this is actually doing absolutely no check to see if t is like blocked or anything. So that should be next edge, that should be next. So first of all we want to record what fraction we got to, then we increase the next fraction. Okay, cool. And for y and z, it's a classic copy-pasty alter thing. So that never goes wrong. I cannot, in living memory, think of a time when copy-pasting things led to any kind of strange behavior. X, Y, Z. Meh. But that's not even in a loop. So let's do while room voxels voxel pos x voxel pos y voxel pos z is 0. T is less than 1 as well. I could have just selected that whole block, but I didn't because I just started hitting keys and that's what happened. Okay, so it's going to do it repeatedly and then it's going to always find a voxel that's solid or it's going to cease. Also, I really think I'm going to just put little values in for the Y and Z because I think feeding zeros into this right now will break it. I have no illusions about that. So in the first room, your reference frame is the same as the room reference frame. We know that the positive angles are up here. Indeed, above us we see the yarn room, which is positive Y, Christmas room positive X, and there's a room positive Z. So if I click here, it makes a block roughly where I am. Did I actually compile this? Also, I'm going to put that swap back on because I don't want to, if I do get this to work the way I intend, I don't want it to just draw lots of blocks. Okay. Well, it's kind of like in front of me, even if that's very close. Which is definitely different to what it was doing, but it feels like it shouldn't do that. What did I say? It should be going 5 units. That's definitely not 5, that's 1 at most. So that's cool. I could just jump in with the debugger, and that is what a human would do. And I'm a human. Definitely human here. No alien DNA. So let's jump in with the debugger just like a human. Easy peasy. Boom. Okay, we're debugging it now. We don't have a mouse. Because I forgot about that. Well, that's fine. We can see nothing useful. Where's the dang mouse? Is it that captured? Oh, it has it. So transform, room pause, room line. It doesn't tell you. It does not tell you what they're set to. Well, definitely moves on the x-axis. And then it's over. Okay. I hit F5 to run the debugger and that stuff. Okay, that's so debugging is a bit bonkers. I really need to fix it so the mouse doesn't get held hostage by the debugger. Anyway, that didn't really tell us much other than it went through X and then it bailed. Why did it bail? T should be less than 1. Was T less than 1? I never actually looked. I think that should be in the screen on the right. So blah 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 T 3.3. That doesn't seem totally accurate. I very much wish I had a mouse pointer. I now have a mouse pointer, so let's have a look. And so let's have a look at some of these things. I'm not really sure how I got my mouse pointer back. Oh, yeah, these are weird unions. Okay, so the room position is something or other. That's cool. Voxel pause is some voxel coordinates. Room line sign. It's a bit like old lang syne. I see, I'm not very good with this. Do. Ah, there you go. Old lang syne. So it's moving positive, yes, because it was 5 and also 0.001. So in fact, room line, the converted room line, should be exactly the same. Yeah, it's exactly the same because this is the exact, this transform matrix is an identity matrix. Okay, cool. So where's the next edge in this example? It is 16 units away. That seems awfully high. So this line where I was like, I'm pretty sure this is correct, is nonsense. That's fine. I'm okay with that. It's because I never took account of the fact that you have to add on the room size there. So let's just do that in a more sensible way. Let's not stop trying to get clever. And I'm right in debugger again where I don't have access to the mouse. Okay, let's just stop. Let's go back to the debugger and hit the stop button. I will definitely track it out, but for now let's have a look. Oh, very good. And if I go up here, let's have a normal. The normal here would be positive or negative x. It's gonna be, well, it's gonna be negative x because I know for a fact this is positive. This is so terrible. And it's never gonna hit these, so let's just say that's the normal. And then I'm just going to ignore that normal thing and just assume that if it didn't land... Oh, this is nonsense. So all I did there was I added a normal, which was going to be one of the cardinal directions, and then I got cold feet about that, and instead just checked if the line never completed because it hit a solid voxel. It's just going to bring it back one on the x-axis. It's forced to going along the positive x-axis anyway, so if this works, there we go. It kind of works. I mean, that's not really what I want to do. I don't know if having that as a cardinal direction is a good idea. Oh. Still very warm in here. I've got my dressing gown on because it was a very cold day. I'm having a little think. So we've got a lot of little vectors set up here. I believe they're all used at least once. Yeah, there's none of them are. But I'm trying to think. What is a good what is a good... So should it return the voxel that it hits if it's solid, or the one that it didn't hit if it's solid? I feel like it should return the solid. Yeah, so if it traces and it hits the one that's solid, then that's fine. It'll just return the solid one, but it needs to return the normal as well. I actually a cardinal direction normal makes sense. If it's like models and other funny geometry, that doesn't make sense, because the normal should be whatever you hit the collision box normal. But because it's a voxel world, normal will be in a cardinal direction, and you can always just use that to vec3 function if you want it as a vec3. I got cold feet because I want to know it's either going to be positive x or negative x here. If roomline sign is less than 0, I really need to name these variables a bit better. Then it's going to be if it's less than 0, it's going to be positive x. If it's greater than 0, it's going to be negative x. But you already know that, which, like, the line is only traveling in a certain way, so it really, honestly, you don't need to you don't need to say that every time. You can pre-calculate. Roomline sign is a vec3, so it's a floating point value. I can use a silly bit hack. I just have to do normals. It's less than 0, it's just going that way. The normal will be positive. This is all very hacky. A lot of this is hacky. I didn't plan out any of this stuff. This is all off the cuff coding. So if it seems less organized and thoughtful than usual, it's just because this is how it usually is. Sometimes I have a very strong idea. I roughly know how to do this, but I'm pretty tired and I'm completely winging it. This is a really ugly solution as well. Anyway, you calculate normal. You know t starts on 0. So I really think it should have like a check there rather than here. Do something in return, or in this case break. Like it should, it needs to return a struct of what happened, and it, well, See, here's the other thing. This doesn't handle room transitions at all. And in fact, what I might do is straight up change this to trace line through room function, and then have an outer loop that calls it repeatedly for each room, because it needs to cross room boundaries and it needs to change reference frame as it goes around the hypercube. But say if it collided, if it did a little collision, then voxel cos plus equals I vec 3 over 2 vec 3 of the normal, and then reset the normal. Okay, so that should handle both cases. Also, our test function, let's make it do it the way the camera is pointing. This will definitely break everything, but I'm not afraid. I am terrified. I'm not terrified. A little bit terrified. So we already know the forwards vector, and I believe that is pre-normalized. So let's just say we're going 10 in the forwards direction, and I'm just going to check if I actually implemented multiply by constant. I did. So now we get to feed in all sorts of different things into the trace line function and see where it puts some cubes. Well, it definitely works there. And there. Well, I say definitely works. Well, that's pretty admirable. Like that's kind of a... So it definitely works is a fairly substantial brag. I'd say it appears to probably work. Is that going over my head? It should really... It's really not quite hitting me. Let's try it in a totally different reference frame. Okay. Weirdly, it kind of comes... So in my mind's eye, imagine if you look in one direction and you keep building blocks, the blocks should head towards your camera, the center of your camera viewpoint. Or they do, but that's a really weird path. It doesn't seem like a straight line. It actually looks like a curved line, like it's a bit wobbly. Oh, that looks like a straight line. Could you fit a straight line through that? Yeah, I guess. Let's try something that's got quite a bit of angle on it. Okay, a bit too close. See, what is that? Is that... Oh, that's actually really good. That is really not so good. I did move. Let's try in this room. Okay, that was actually perfect. I'm probably just very near the edges of the cells. The cells are quite small. That definitely seems wrong. It seems wrong-ish. Oh, that's got to be wrong. That has to be wrong. Look, that's an actual curved line. Who could... There's definitely errors in the calculation. But I could make a bunch of stuff. Okay, so let's have a quick think. Oh, actually, did I set any of those normals correctly? Oh. Seems like I did. Okay, so let's have a think. I'm probably going to end the stream pretty soon. So that was all very experimental. What worked well? It generally worked. It seemed like I was tracing lines with reasonable accuracy. That was good. What didn't work? I would guarantee any edge case will currently fail. Or corner case. They're just not handled. I mean, I put this in checking if the sign is not 0 in a nasty way, but I wouldn't be surprised if that fails. What else does not work? It doesn't handle room transitions, nor is the code very well structured for that. Also, this is very messy. This is uninitialized and potentially could remain uninitialized. In fact, it's uninitialized here. If you're inside a solid voxel, that while loop is false, none of this code is executed. T is definitely less than 1, and then it's going to add straight on. So that's straight up adding uninitialized nonsense onto the voxel position, so that's certainly wrong. This little hack was very good, I like that. So no rim transition. So I think this general core loop is close to the right thing. I feel like I need to do a little bit more to keep the reference frames correct. Possibly possibly I think I got an idea with that. So when it moves from one room to the next room, it will need to reconvert everything. So what I can do is move the reference frame and recall the function. So overall, it was a good experiment. There's lots of bits that don't really work. Hacking it through the script was really easy. As always, make sure you put scripts in your game so you can just do like one line of code and then just stick it in a script and have it all controllable. I could stick whatever I want there. Hooray! I added a button and it just all... Yeah, I just added a button, hooked it up to the mouse, and it was straight in the script. I mean, that's not super useful. I could have done that in code in about the same amount of lines. But it's nice to have that kind of dynamic aspect. It's certainly useful later on when you want to add something to a level, but you don't want to make it code. You just barf it all into a script, and you're like, off we go! Okay. I'm staring at this a lot. I'll chip away at it tomorrow, and then I'll see if I can get it to behave nicely. I'm still a bit confused why it's doing that. Sort of, you'd expect it to be like a sequence of blocks that's an exact pattern, but it was doing like 2 this way, then down, left, down, then 2 that way, and then doesn't quite gel in my mind. So we got a lot of extra changes here. Always commit all your changes. These changes are kind of garbage, so I'm going to check out a branch called trace line, and I'm going to commit it on a branch because I can. It's I was going to say likely buggy, but all code is likely to be buggy. Test version not incorrect, incomplete. That's what I meant to type. I mean, it's incorrect as well. Test version, test trace line code. I cannot because it wants it to be pushed to upstream. Boom. And I knew it was going to say that, so that's why I did it. Oh, I can open a pull request. Well, I wouldn't, because the person who code reviews it, me, will not accept this. I'll say, that's not right. Boom. Nice diagrams. Oh, okay. It's very late. I don't know if anyone watches these things, but if you had fun, then let's go. I'm happy for you. I'm going to have to say bye-bye because it's time for me to hit the hay. Goodbye!